In this video, I want to have a look at angles of any magnitude. So when we're measuring angles on our number plane, we start here at 0 degrees and we move in an anti-clockwise direction. So this is 0 degrees, we've got 90 degrees, 180 degrees, 270, and if we come back around, we'd end up back at 360 degrees. Now we could keep going. So every angle, just like this arm here, is 0 degrees and 360 degrees. Every angle will have an infinite number of ways we could express it. If we just kept going round and round the circle, we'd just keep moving up the numbers. So to make that make a little bit more sense, if this angle here was 40 degrees, then we could say that that arm was on an angle, we could just say 40 degrees. But if we went, instead of just starting here and coming up, if we went from here, we went all the way around, so we've gone a full 360 degrees, and then we come up another 40, we could write that as 400 degrees. So that arm could be representing an angle of 400 degrees. So that's coming up to the 40, then going around one whole revolution. If we were to go around again, we would end up at 760 degrees. But that's going in the clockwise direction. If we were to start here, so start at 0 degrees and move clockwise, we'd come around here and we'd actually end up at minus 320 degrees. Again, if we went all the way around to minus 320 and then went all the way around another revolution, we could end up at minus 680 degrees. So there's an infinite number of angles that that arm could be representing. Let's have a look at another example. So in this one, we've got an arm here and we've got this angle in here is 70 degrees. But we always measure angles from this positive axis over here. So we actually want this angle here. Now together we know that because they make that straight line down the bottom, they have to add up to 180, which means that this line here, that angle there is 110 degrees. Okay, so that's one way that we could represent, or one angle that could represent that arm. So that's 110 degrees. If we were to start here and go all the way around and then back up to there, we would have 470 degrees. If we were to go around a whole nother revolution, we'd have 830 degrees. And that could go on forever if we just keep going around in circles. If we were to start here and go clockwise instead, we'd come around 180 and then another 70. So we'd end up at minus 250 degrees. So if we were starting at 0 degrees and going clockwise instead. So if we went around to minus 250 and then went around a whole nother revolution, we'd end up at minus 610 degrees. So just emphasizing there's an infinite number of ways that we can represent that angle. Next thing I wanted to have a look at is our unit circle. So we've got a circle here and it's got a radius of 1, so it's our unit circle. And we've drawn in a right angled triangle. Now to do that, we've gone from the point where that radius meets our our circle. We've dropped a vertical line until it hits our axis. So if we move that, wrong button. If we move that, you can see that that triangle is always formed so that it drops is a vertical line to the x-axis, so never to the y-axis. Right, so let's put it back up here for a second. Over to the side here, we've got sine, cos, and tan of this acute angle inside that triangle. Now what you can hopefully notice is that sine of that angle is 0.73. And that's because from this angle, sine we know is opposite over hypotenuse. So opposite is that 0.73, but our hypotenuse is just 1 because it's a unit circle. So sine of this angle is just going to be the x-coordinate of this point, the y-coordinate of this point. Cos is 0.69, so it's our x-coordinate because it's this distance along here. So this is our adjacent side divided by our hypotenuse, but again, because our hypotenuse is 1, it's just going to be the length of our adjacent side. So that's our x-coordinate. Now tan is opposite over adjacent, so that's going to be this one here divided by this one, so opposite over adjacent, which is actually the same as going sine divided by cos. All right, so let's move that around and see how it still works. So if we were to move it up here, sine is 0.93, that's our y-coordinate. Cos is 0.36, that's our x-coordinate. And if we were to go 0.93 divided by 0.36, we'd end up with 2.61. If we move this over this way, So we've moved it into the next quadrant. This gets a little bit messy with all our numbers, but what you can still see on there are our x and our y coordinates up here. So our x coordinate is minus 0.58 now, and that's our cos. So cos is minus 0.48 because our x coordinate is negative. Sine is still positive because we're still above that x-axis, so our y coordinate is still positive. It's 0.82. And if we go a positive number divided by a negative number, we're going to get a negative. So tan is negative in this quadrant as well. And that'll happen for any angle that's in that quadrant. If we move down to our third quadrant, so down here somewhere, we've still got that our x coordinate at that minus 0.72 is our cos. Our y coordinate is minus 0.7, and that's sine. So in this quadrant, because our x and our y coordinates are both negative, sine and cos of this angle are both negative as well. Now tan, because we're going opposite divided by adjacent, and that both those things are negative, going a negative number divided by a negative number, tan will be positive down in this quadrant. All right, our last one over here. Still works the same. Sine is negative this time though, because our y coordinate is still negative because we're below that axis. But because we're on the right, our x coordinates are positive, so cos is positive. And again, because we're going a negative number divided by a positive number, tan will end up being negative as well. All right, so I'm going to give you guys access to this so you can have a play with it as well if you're interested in having a bit of a closer look at it. But that's just a few examples of angles of any magnitude and how they relate to our three trig functions.